Very good afternoon, everyone, and happy new week. I'm so glad to see your faces once again after a period of about 1 week plus. We are looking at a new series starting from today, and we are talking about simultaneous equation, one linear, one quadratic. I'm aware that we have done simultaneous equation in our junior high school. The difference between that and this is that in that one, you looked at simultaneous equation in two linear variables. It could be x and y, a and b, p and q, and so on and so forth. All right? But this one is, one of them is linear and one of them is quadratic. In that one within your junior high school, both were two linear equations, and you obtain a variable you obtain an answer for the first variable and another answer for another variable, making it a total of 2. But in this, you are going to be having a total of 4 answers because there's a quadratic equation involved. So one quadratic equation will produce 2 answers for one of the variables, and we now put each of those answers into another equation to obtain 2 different answers also for the second variable, making it a total of 4. All right? Good. So right away, let's look at our example 1. Find the values of x and y in this equation. So what you are going to do is to pick any one and make your first equation and second equation. So I can just pick them as they appear by saying that 2x minus y is equals to 10. I call this my equation 1, and then 3x plus y squared is equals to 22. I call this my equation 2. Okay, so you know that it is mathematically balanced because 2 variables, 2 equations. All right, so what do I do here? I will now say from equation 1, I normally use the simpler equation to make subject of the formula. All right, I want to use substitution method. You can as well use elimination if that is what you prefer. But throughout this series, I'm going to be using substitution method, except I encounter a question that elimination will be faster. All right, so from equation 1, all right, if my minus y go over to the right-hand side, it's going to become plus, and if 10 come to the left-hand side, it's going to become minus. So I'm going to have, from equation 1, all right, from equation 1, what do I have? I'm going to have 2x minus 10 is equals to y, and I call this equation 1, but modify, so it is now equation 1b. All right, so what do I do now? When I say put 1b into equation 2. So we now replace y in equation 2 with this. All right, equation 2 says 3x plus y squared, but instead of y now, I'll put 2x minus 10, but it is squared, so all squared equals to 22. So I have replaced this y squared with 2x minus 10 all squared. So I will have 3x plus expanding 2x minus 10, it appears twice, that's the meaning of the square, equals to 22. On further expansion, 2x times 2x will give us 4x squared, 2x times minus 10 minus 20x, 10 times 2x minus 20x, minus times minus will give us plus 100 equals to 22. Rearranging in our descending powers of x, so I will now write 4x squared first, then this is minus minus to give us minus 40x, then plus 3 give us minus 37x. This one come over to the right hand side, become minus, so 100 minus 22 give us 78. So plus 78 equals to 0. All right, so this is the resulting simultaneous equation in one variable. Here was a simultaneous equation in 2 variables, x and y. All right, so it is not purely in x, so we cannot solve for x. What we do is we factorize. I don't really know whether this number is factorizable, except I test it. But rather than wasting time testing, I can just use formula method. All right, since the product of the coefficient times 78 is going to be very large, so using formula method is going to bail us out at this point very fast, instead of wasting time testing, and at the end it will not even be factorizable. So we now see our coefficient A for x squared is 4, our B is equals to minus 37. Please, it's not 97. When you write a number, always write it with its sign. So, and our C is 78. What is the formula method? Remember, remind me, S is equals to minus B plus or minus square root of B square minus 4AC, and everything divided by 2A. So when we substitute, what we have, X is equals to minus, is the minus, B is what, minus 37, so we still include that minus 37 there, okay, plus or minus square root of what now, minus 37 all square, minus 4 multiplied by A is 4, and times C, which is 78, and everything divided by 2A, which is 2 times 4. All right, so minus minus is plus. What then do we have? We're going to have X is equals to 37, all right, plus or minus square root of what? Minus 37 all square. What do we have if we do that? 1369. So we're going to have 1369. Please confirm. And minus, what again? Minus 4 times 4 times 78. I'm having minus 1248. Somebody please confirm. Everything divided by 2A, which is 2 times 4, which is 8. Okay, so when we subtract, simplify our root, we're going to have X is equals to 37 plus or minus square root of 121 over 8. And square root of 121 is 11. So X is equals to 37 plus or minus 11 over 8. At this point, you can separate the different signs. S is equals to 37 plus 11 over 8, or 37 minus 11 over 8. And of course, you finish solving the two of them. What do you have? We have X is equals to 6, or X is equals to 13 over 4 are the answer. So we have gotten the two values of X as I mentioned earlier. So what do we do now? We have not gotten Y. Y is a simultaneous equation. So when I say using equation 1b, what does it say? What did equation 1b state? Y is equals to 2x minus 10. So Y is equals to 2x minus 10. Alright, so I want to use this equation now to find the value of Y since we have the value of X. Okay? So when I say when X is equals to 6, put it into equation 1b, Y is 2 into 6 minus 10, and your guess is as good as mine. Y is equals to 2. Presenting our answer in coordinate form or a pair of answers X and Y. So now say X is 6, Y is 2. So when X is the second value, 13 over 4, what's our Y? That implies that Y is equals to 2 into 13 divided by 4 multiplied by 4, 13, 2 into 13 over 4 minus 10. And when we simplify this, what do we have? We have our Y, so Y is equals to minus 7 over 2. So if we present also in a pair of points, we say X is what? 13 over 4, comma, minus 7 over 2. So those are the two values of X and Y. Alright, so these are the two answers, this and this. You can see that there are 4 answers altogether. Any question? Any question? Alright, no question. Let's look at question number 2. Alright, perfect. Understood. In question number 2, we are given these equations that have been labeled already as 1 and 2, but it is in variable P and Q. So if you look at this, you can start with any one if you want, but it's easier to start from equation 1 to make it solve the formula, though you can also start from equation 2. Alright, so anyone can be used. So I use equation 1. So I will now say from equation 1 that my 2Q is is equals to 12 minus 3p. All right, if 3p go to the right hand side, it becomes minus. So dividing both sides by 2 to find our q is 12 minus 3p divided by 2. And I'll call this equation 1, but modified 1b. And notice the way I normally give it a parent name of 1 to avoid student making mistake. So student will call this equation 3. That doesn't matter. You can call it any equation 5, 10, 1 million. It's your business. But don't forget, when you are substituting, don't go and say put equation 3 into equation 1. Equation 1 and this equation 1b are the same thing, but it's just that they are existing in different form. All right, just like when you have 2x plus 6 is in as 2 into x plus 3. All right, this is the factorized form, and of course this is the expanded form. So they are the same thing but in different forms. All right, so equation 1 and 1b are the same thing. So I will not go back and put into equation 1, but I'll put it into a different equation altogether. So I will now say put 1b into equation 2, which is a different equation altogether. So I will now have p multiplied by q, and my q is what? 12 minus 3p over 2, okay, plus 5q, 5 multiplied by again 12 minus 3p over 2, all right, equals to 21. Expanding, what do you have? We are going to have 12p minus 3p square over 2, okay, then plus 60 minus 15p over 2 is equals to 21. We clear fraction by the LCD, and that is 2. 2 into 12p minus 3p square over 2 plus 2 into 60 minus 15p over 2 is equals to 21 multiplied by 2. So I have cleared the fraction, and when I do that, my fractional equation will be converted to whole number equation. So I will now have 12p minus 3p square plus 60 minus 15p equals to 42 on the right hand side. Now we can see that it's not a quadratic equation in one variable. So we put this everything on the left hand side to the right hand side. And let me remind you quickly, you can see that this equation, this question 2, is a typical example of a pseudo-quadratic equation, because you can see the equation 2, it is a product of two variables p and q. All right, so that's why I also recognize that this is also going to lead us to simultaneous equation, one linear, one quadratic, because when you have x times x, you're going to have x squared, because while you're having x power 2, because it is the same variable, but here it's also a variable times another variable, but it is not power 2 because they are different variables. That's why having that p and q. However, that's why it's leading us to quadratic equation, as you can see here. All right, so if I transfer all these terms to the right, so nothing is going to be on my left hand side again. So I'll say 0 is equals to 42, which is already on the right, then minus 12p if it comes over, plus 3p squared if it comes over, minus 60 if it comes over, plus 15p if it comes over. So just rearrange, okay, writing all this first, then equals to 0. All right, x is equals to y, meaning that y is equals to x. So this now I want to write it first, starting from the highest power of p and descending down to constant terms. So I'm going to have it as 3p square. Then the next value of p is, this is minus, all right, this is minus 12p, and this is also plus 15. So are you seeing that I'm going to have it as what? Minus plus is plus, so I'm going to have it at plus 3p. And what do we have again? Then 42 minus 60 is going to give us minus 18. Minus 18 equals to 0. So is it factorizable? Let's test, of course, factorizable. 3 times minus 18 is going to give us minus 54. Factors of That will give us 9 and 6. That's minus 54. And we can use 9 and minus 6 to replace what we're going to solve here. So the two factors we use are 9 and minus 6. So going to the other side, I'm going to have 3p squared plus 9p minus 6p, the minus 18 equals to 0. By grouping, if factorize by grouping, 3p into p plus 3 minus what is common, 6 is common, p plus 3 equals to 0. Remember the two brackets must be the same. So 3p minus 6 into p plus 3 equals to 0. And what we have, you have your p is equals to minus 3 when you solve for this one, and or p is equals to 2 when you solve for this other one. All right, any question? Okay, so these are the values you now use to find your Q. So now say using, so we have gotten the two values of P using equation what? Where Q was defined, equation 1b, which is 12 minus 3p over 2. Q is equals to 12 minus 3p over 2. All right. When I say when p is equals to minus 3, okay, what is our Q? Our Q is equals to 12 minus into 3 minus 3 times 3 over 2. And our Q minus minus is plus. That will give us 21 over 2. All right, so we can present it as a pair of points. X comma y is going to give us, we have it as minus 3. Okay, this is p comma q now, not x comma y. I'm used to x and y. So p comma q is equals to minus 3 comma 21 over 2. So those are the pairs of solutions. So when p is equals to 2, using the same equation 1b, which is this, our q will give us 12 minus 3 into 2 over 2. And that will give us 3. All right? Because this will give us 6, and 12 minus 6 is 6, and 6 divided by 2 is 3. So q is equals to 3. So now have it as p comma q as a pair of answer is equals to 2 and 3. So remember, see the way they appear, p fell before q. So also the answer for p, which is 2, before the answer for q, which is 3. So these are the solutions for this question 2. Any question? Any question? All right, perfectly understood. Let's look at the third example for this episode. In question 3, we are told here that if 4x squared minus xy minus 10 equals to 0 and 3y minus 4x minus 1 equals to 0, find x and y. Okay? So let's just start with a simpler equation. So I will call this my equation 1 and call this equation 2. All right, anyone can call the equation 1 or 2. Okay, so that's not a problem. So I say 3y minus 4x minus 1 is equal to 0. My equation 1. And 4x squared minus xy minus 10 is equals to 0, my equation 2. All right? So from equation 1, what do I have? 3y is equals to 1 plus 4x. If minus 4x go over to the right and minus 1 go over to the right, this is what you have. So y is equals to 1 plus 4x divided by 3. So equation 1 but has been modified as 1b. So put 1b now into equation 2. Put 1b into equation 2. So 4x squared All right, here equation 2 is a quadratic equation but in 2 variables, but by the substitution we are about to make now, we will revert back to quadratic equation in 1 variable. That's what we want to do. So 4x squared minus x, then what is y? We'll now put the value of y, which is 1 plus 4x divided by 3. Okay, then minus 10 equals to 0. When we expand, we are going to have 4x squared minus, using the x to expand. Okay, so I'll just do the minus first. Just expand with the x. So I'm still going to be having x plus 4x squared over 3. The minus 10 is equals to 0. I have not used this minus. All right, remember I've not used this minus. If I use this minus, of course, here could have a minus and here could have also been minus. So I've not used the minus. Remember that. Okay, so clear fraction by the LCD, and who can tell me? Of course, the LCD is 3. All right, so if I use 3 to multiply both sides, clear fraction. So what we have? We have 3 times 4x squared will give us, okay, let's set it, 4x squared minus 3 into x plus 4x squared over 3, the minus 10 multiplied by 3 equals to 0 times 3. So multiply everything by 3. So this will give us 12x squared. This will cancel this. All right, we have minus. So using the minus to expand, minus times x now we have minus. So see, we apply the minus now. Minus times minus will give us also minus 4x squared. Then minus 30 equals to 0. And 12x squared minus 4x squared will give us 8x squared. Then minus x minus 30 equals to 0. All right, so what do? We factorize, and of course use the coefficient of x squared to multiply. So when you factorize, you can also use your formula method. All right, you can use completing the square if you want. So when you factorize, you're going to have 8x plus 15 into x minus 2 when you factorize equals to 0. So when you solve for this one, you're going to have x is equals to 2, or when you solve for the other one, you're going to have x is equals to minus 15 over 8. So these are the 2 solutions for x, but we have not gotten the 2 solutions for y. So using equation what now? Equation 1b. Using equation 1b, which is y equals to 1 plus 4x over 3. Am I correct? Exactly. So what we have, when x is equals to 2, that implies that y is equals to 1 plus 4 into 2 divided by 3, and that will give us 3 as the answer. So as a pair of value, x and y is equals to 2, 3. When x is equals to minus 15 over 8, what is our y? Y is equals to 1 plus 4 into minus 15 over 8, then everything divided by 3. I'm avoiding multiple fraction. Always remember how I try to avoid multiple fraction in order not to confuse you. All right, of course, 4 we cancel this, 4 we go here and cancel here, you have 2. Then you now have it as y is equals to 1 minus 15 over 2, and everything divided by 3. That's what you're going to have. Okay? Any question? And when you finish up, you're going to have your answer to be y is equals to minus 13 over 6 as the final answer. So presenting as a pair of points, x comma y, we're going to have it as x is minus 15 over 8, comma y is minus 13 over 6. All right, so these are the two answers for y also. All right, so you can see that we have solved three different simultaneous equations, one linear, one quadratic. So this is how questions are being solved. So we follow the same approach that you have learned in your junior high school in solving simultaneous equation in two linear variables. But the only problem here, or the only advanced thing that's added to the knowledge, is that one of those equations that you are used to is left as linear, and one of them now is changed to a quadratic equation. So you now combine them together. That gives you one linear, one quadratic. So one quadratic will produce two answers, all right, for one variable. And you now take each of those answers, produce another value of the second variable, take the second answer, produce another answer for the second variable, making it 2, 2 each. And when you combine the two answers, you have 4. So you can see that we have 4 answers in all, 2 here, and of course 2 here, are seen in all the examples we have considered, example 1, 2, and 3. All right? Any question? Any question? All right, perfect. No question. So before you go, I'm going to give you a practice question to do. And of course, I want you to file your answers and tell me what you have. Here is your practice question. All right, so the first one says 3x squared minus 2y equals to 42, 2x plus 3y equals to 17. And you can see the answers are there, so solve and verify. Then the second question says xy equals to 21 and x plus 5y equals to 22. You can also see the answer, the pair of answers here, solve and also verify. This is the end of this episode. Thank you very much for watching. Thank you for coming to the class. And to our online viewers, please do subscribe to this channel if you haven't, and recommend to schools and students looking for study materials in mathematics. It is a goodbye from me till we meet in the second episode, where we'll consider further problems and also we'll look at word problem leading to simultaneous equation, one linear, one quadratic. Until then, it is a goodbye. Thank you for watching.